Hello, good afternoon students. How are you? Welcome to one more fabulous session from Infinity Learn. I am Suresh, Faculty of Chemistry from Infinity Learn by Sri Chaitanya. Good afternoon. How are you all? Hello, Richa Sharma. Hi, good afternoon. Nice to see you on the screen, right? Okay, one more student is there, right? Good. Hi. So, in this marathon sessions of NEET Step Up 2025 program, we are in hydrocarbons, alkenes. So, in this NEET 2025 Step Up program, this program is especially meant for those students who dropped at 12th standard and preparing for NEET 2025, and also these sessions are meant for those students who are in 11th standard completed and stepped into the 12th standard. They can also get advantage of these sessions, and these sessions are planned in such a way that afternoon 12 o'clock to evening 6 o'clock total physics, chemistry and biology sessions are being given. Both 11th standard and the 12th standard, from the NEET perspective, the syllabus is completed at NEET level. Hello, hi. So, very good. So, please join these sessions on a regular basis every day and get advantage of these sessions that we are giving from Infinity Learn by Sri Chaitanya. So, my dear students, why late? We start here. So, as far as these chemistry sessions are concerned, we start with Monday, Tuesday, Wednesday and the 11th standard syllabus we discussed, and the Thursday, Friday, Saturday grade 12 is going to be discussed, right? So, yesterday we started hydrocarbons, alkenes. In the previous sessions we completed general organic chemistry, isomerism, electronic effects, and hydrocarbons, alkanes we completed, and yesterday's class we discussed alkenes preparation. Richa, you are there in yesterday's class? Right, that's good. Very nice. Okay, now let's see what we learned in yesterday's class. So, we learned introduction about the alkenes, general formula and their structures, and the preparation of alkenes. Under the heading of preparation of alkenes, we have seen so many methodologies. If you recall, dehydration of alcohols. In the dehydration of alcohols, alcohol, if water is removed, you are going to get alkene, right? So, this follows formation of a carbocation. So, the dehydration of alcohols, formation of a carbocation means the product that is formed according to the stable carbocation. So, dehydrohallucination. Dehydrohallucination means removal of halogen and removal of hydrogen. Together is removed from alkyl halides by using a suitable base which follows Seder's rule and Hoffman eliminations. So, when to use Seder's rule, when to use Hoffman rule? When general cases we use Seder's rule, and whenever the base is bulky, whenever the leaving group is a poor leaving group, we have to use Hoffman rule, right? So, more substituted alkene is the product according to Seder's rule, and less substituted alkene is the product according to Hoffman rule. If you recall all these things, well and good, my dear students. If not, please watch the recording that is available on the NEET channel by Infinity Learn. Right, students? So, any more there? Please give a thumbs up or a fire emoji in the chat box. Great. और क्या किया इसके अलावा? Dehydrohallucination, फिर भी Kolbe electrolysis किया. If you remember, Kolbe electrolysis we discussed in alkanes as well as here alkenes we discussed. Okay, in the chat box you can see Telegram channel is printed there, so you just tap it on and join in the Telegram channel so that you will be getting a very good updates on it. So, what आगे class क्या है, इसका class का material क्या है, okay, all updates about the NEET you are going to get in the Telegram channel, right? So, also we discussed about the physical properties, if you remember, right? Cis alkene and trans alkene. Cis alkene dipole moment is not equal to 0, trans alkene dipole moment is going to be 0. if both alkyl groups are same, right? So based on that, boiling point and melting points are given there, right? Okay, let's talk about आज हम क्या करना. रिचा गेस मारो एक बार थोड़ा सा गेस मारो. आज हम क्या करना चाहता हूं. सो ये कल का क्लास है, क्या सुना है, क्या लिखा है ना. आज क्या करने वाले हैं. So what you learn in this today's session. Today we are going to see the chemical reactions of alkene. So in that chemical reactions we'll discuss about hydrogenation, addition of hydrogen, electrophilic addition reactions. Electrophilic addition reactions, you have halogenation, hydrohalogenation, hydroxylation. Many things can come in this sequence. फिर भी at the end we are going to discuss about ozonolysis, analysis of alkene. So this is the main course for today's class. Are you getting ready, Richa? Right. So let's talk about chemical reaction. Hydrogenation. Hydrogenation of alkene होता है क्या? So hydrogenation, so here you can see when alkene, let us say this is alkene, when hydrogen is added in the presence of some kind of catalyst, okay, or you can use platinum, you can use palladium, right? So that hydrogen is being added here, so that CH3 and CH3. So this is what you call it as hydrogenation. And एक चीज है, उसे this is an exothermic reaction and we discussed जब हम hyperconjugation पढ़ा रहे हैं. So the heat released when 1 mole of hydrogen is added to an alkene is called heat of hydrogenation. याद है? Yes, it is an hyperconjugation. So this quantity tells many things. That is what you call it as heat of hydrogenation. This is your heat of hydrogenation. The energy released when 1 mole of alkene is hydrogenated is called heat of hydrogenation. So this is exothermic process or endothermic process. Ishita, hi, good afternoon. You are 10 minutes late today. Okay. Is it an exothermic reaction or endothermic reaction? Ishita, बोलना. Exothermic or endothermic? जल्दी बोलना, फटाफट. हाँ, heat is released. Heat is released. So that is, don't say sorry dear. Today I am 1 minute late. Do you know that? Okay, no sorry between you and me. Come on, jaldi. So heat is related. So this is exothermic reaction. As this is exothermic reaction, delta H का वैल्यू नेगेटिव होगा, पॉजिटिव होगा, नेगेटिव होगा. थर्मोडायनेमिक्स का हिसाब से रिचा शर्मा, यू सेड करेक्ट. सो दैट इट इज नेगेटिव. अगर ज्यादा एनर्जी रिलीज किया जाएगा तो ज्यादा नेगेटिव वैल्यू होगा. दैट इज व्हाट इज सेड. More the negative the heat of hydrogenation of alkene, less is the stability. So I just want to say stability is inversely proportional to heat of hydrogenation. Stability of an alkene is based on this particular tip. So based on this particular tip, my dear students, you can expect questions from the NEET examination. That's quite important concept, right? So when you talk about trans-but-2-ene means, see, this is trans-but-2-ene and cis-but-2-ene. This is the structure of cis-but-2-ene, बच्चों लोग. You can see, and but-1-ene, CH3, CH2, CH double bond CH2. So in this, the heat stability follows this order like this, like this. Why? Because इसका heat of hydrogenation ज़्यादा से ज़्यादा होगा, इसका heat of hydrogenation कम से कम होगा, है ना. सो जिस आल्कीन का हीट ऑफ हाइड्रोजनेशन कम है उस आल्कीन का स्टेबिलिटी ज्यादा होगा, राइट? सो आई जस्ट वांट टू कन्विंस दिस पर्टिकुलर कॉन्सेप्ट बाय यूजिंग एक्सपेरिमेंटल डाटा भी. यू कैन सी butadiene, if you add hydrogen in the presence of platinum, आपको कितना हीट निकल रहा है? So it is minus 127 kilojoules heat is released, right? When you talk about cis-butadiene, the heat of hydrogenation इससे और थोड़ा कम निकल रहा है ना? When you talk about trans-butadiene, look at this value, it is minus 115 heat is released. If you see the magnitude of the heat of hydrogenation, I just want to write heat of hydrogenation simplified version में. So butadiene is greater than cis-butadiene is more than, कम से कम इसका है ट्रांसब्यूटेन का, समझे बेटा? क्लियर रीचा? ना इसका उल्टा कर दो, इसका स्टेबिलिटी उल्टा होगा. मैं क्या बोल रहा है? स्टेबिलिटी इनवर्सली प्रोपोर्शनल टू हीट ऑफ हाइड्रोजनेशन. हीट ऑफ हाइड्रोजनेशन, अभी तो हीट ऑफ हाइड्रोजनेशन का उल्टा करके स्टेबिलिटी लिख सकते हैं बेटा. सो ब्यूटेन का उस तरफ जाना, सो ट्रांस ब्यूटेन एंड सिस एंड ब्यूटेन, समझे? सो दिस इज ए ट्रिक आई वांट टू गिव to follow the examination in the NEET exams. Stability is inversely proportional to heat of hydrogenation. Hope you all understand. Please give thumbs up or fire emoji if you understood about the heat of hydrogenation. This is the experimental data. मैं आपको convince करेगा, आपको दिखा दिया यहाँ पर. So I just want to say this is the order of stability. दिस इज द ऑर्डर ऑफ स्टेबिलिटी. ये स्टेबिलिटी सीधा ऐसे मत याद करना. सो ये स्टेबिलिटी आप अल्फा हाइड्रोजन नंबर पकड़ के बोल सकते हैं. अल्फा हाइड्रोजन नंबर इज डायरेक्टली प्रोपोर्शनल टू नंबर ऑफ हाइपर कॉन्जुगेशन स्ट्रक्चर. more number of hyperconjugation structure, more is the stability. If you miss this hyperconjugation structure, you just follow the previous lectures that is available in the recorded board, right? You can see, right? Clear? That's good. Ishita, fine? Great. Now let's see. And this is heat of hydrogenation, right? फिर भी आपको heat of combustion भी आएगा. What is the meaning of heat of combustion? Heat of combustion means when alkene is subjected for burning, it burns like anything, right? So heat is released. That is also exothermic process. So when the hydrogenation of alkene does not give the same alkane, the heat of combustion is used to measure the relative stabilities. ये दूसरा मेथड है स्टेबिलिटी निकालने के लिए, है ना? सो मोर नेगेटिव वैल्यू ऑफ हीट ऑफ कंबस्टन, लेस स्टेबल इज अ कंपाउंड और वाइस वर्सा. फिर भी यहां पर सेम लॉजिक इस्तेमाल करना. सो स्टेबिलिटी इनवर्सली प्रोपोर्शनल टू हीट ऑफ कंबस्टन. हीट ऑफ कंबस्टन फिर भी एक ट्रिक है. ये ट्रिक आप नीट में इस्तेमाल कर सकते हो बेटा. सर अरे नीट निकालना अच्छा तरीका, आपका बहुत आसानी काम है. सिंपल ट्रिक्स आर देयर. इफ यू कीप पिकिंग दिस टिप्स ना, यू कैन डू द बेस्ट, राइट? ओके, राइट. सो अगेन विल सी हीट ऑफ कंबस्टन. butadiene, when you go for the combustion, it is going to give you 2720 kilojoules, and cis-butadiene minus 2710. Look at the magnitude, don't look at the negative sign. And trans-butadiene 2705, and this is 2-methyl prop 1-ene. It is also said to be isobutylene. So isobutylene on combustion gives rise 2700. So what I mean to say here, heat of combustion values किसका ज्यादा है? 2720 is more, so but 1-ene more than cis-butene is more than trans-butene is more than isobutylene, right? This isobutylene. Now let us talk about the stability. Somebody tell me, Ishita, you tell me the order. Reverse करके बोलो, chart box में reverse करके बोलो. Stability order. Yes. Now that is isobutylene is more than trans-butene and more than cis-butene and but 1-ene. मैं एक चीज बोलना चाहता हूं, this is very important. Isobutylene is more stable than trans-butene. That's a very important. नीट में पूछा जाएगा आपको. Fine? Any doubt? Clear? Okay. So, my dear children, any doubt you please put in the chat box. I am ready to give you the correct answers for what you ask in the class. Come on. नहीं, डाउट नहीं है सीता, ठीक है. आगे बढ़ो. मैं एक क्वेश्चन है, कल का जो क्लास है, एक क्लास के हिसाब से मैं एक क्वेश्चन तैयार के रखा हूं. गिव द प्रोडक्ट्स देयर स्टीरियोइसोमर्स if any stereoisomers are there, carbon and carbon. If but2-ine is treated with H2 in poisoned with palladium, कौन सा पॉइजन इस्तेमाल कर सकते हैं आप? बेरियम सल्फेट इस्तेमाल कर सकते हैं. एंड but2-ine can react with sodium and liquid ammonia, okay, and sodium and liquid ammonia with the same thing. It doesn't matter, only two products you just give it to me, okay. So if you see different versions, the answer, when H2 and PD poisoned with barium sulfate and or calcium carbonate, Lindlar catalyst suna, so that it is going to be a syn addition. A syn addition का वजह से hydrogen comes on the one side of the triple bond, so that double bond, so that you have cis-but2-ene. Cis-butene is formed. That is very important. If it is sodium and liquid ammonia, it is anti-addition, so that you are going to get hydrogens on the opposite side. Therefore, you are going to get a trans-but2-ene. Okay, you don't have to worry about this. You just focus on these two. Fine. So it is again hydrogenation. Okay, controlled hydrogenation you can say. It is a controlled hydrogenation, right? That's fine. Good. Okay, so let's go ahead. So can you give the product? I just curious to know what product you can get. Yes, what product you can get? Ishita, Richa Sharma, come on, what product you can get? You just tell me in the chat box. Let it be wrong, I am going to correct you. No worries. So when cis-2,3-dibromo-but2-ene is treated with H2PDC, so what you are going to get? So simply hydrogenation takes at one side of the double bond. Okay, so you don't use this. Okay, hydrogen in the presence of palladium. So actually hydrogenation is taking place by using a catalyst. surface catalyst, so that it is any surface catalyzed addition reaction is syn addition. Syn addition means addition from the one side of the plane, that is called syn addition. If addition takes place both sides of the plane, that is called anti addition. Here syn addition takes place. So this is a cis isomer. So if hydrogen is added here, this is your product. This is your product. If you look at this product, this is a carbon. Look at this carbon carefully. This carbon is a stereo center. This carbon is a stereo center. Okay. So a stereoisomer is generated. So I just want to say, I want to take this methyl group and this methyl group and take in the linear way. So instead of writing like that, I just want to write like this: methyl group, a carbon, and this is a methyl group. जो bromine है, hydrogen है, it comes like this, and also comes like this. Because hydrogen is added from the one side, it is shown like this. Now if you look at, this is a chiral carbon, this is a chiral carbon. But if you recall stereochemistry and plane of symmetry, isomerism we discussed previously. Recordings are always available in the NEET YouTube channel. You please go through that, you will understand. There is a plane, this is what you call plane of symmetry. ये प्लेन ऑफ सिमेट्री के वजह से ये ऑप्टिकली इनएक्टिव होगा. सो दिस कंपाउंड इज नोन एज मीसो कंपाउंड. दिस कंपाउंड इज नोन एज मीसो कंपाउंड. मीसो कंपाउंड जो है ये प्लेन ऑफ सिमेट्री का वजह से ये ऑप्टिकल इनएक्टिव हो रहा है. That is called meso compound. The product is meso 2,3-dibromobutane and it is optically IA, inactive. Clear? That's a tremendous example. If you get any type of questions, difficult questions, more than this difficulty level, you don't expect it. So this is the best way to understand the addition of hydrogen. It is stereospecific. Okay, a stereospecific reactions are the reactions a particular stereoisomer gives a particular stereoisomeric product. Such reactions are called stereospecific reactions. Understand? Okay, आगे बढ़ो. कुछ डाउट है क्या? चल. Great. Any doubts are there? You please put in the chat box. You please click on the links that are given so that you will be getting a continuous updates in your device, and also you are going to get such a valuable notes in the PDF form at the end of the session when you join in the Infinity Learn Telegram channel, right? Yes, Faraz Alam, that's good. Optically inactive. So yesterday you are not there, Faraz. Are you there in the class? Okay, right. So let's go ahead. Chalo. Fine. And Google form bhi diya gaya. So if you fill that Google form, you will get total updates. Okay, and any offers are there in any class, you are going to get it. Okay. So Devanshi Tripathi, optically inactive. Yes, great to see. Okay. Ishita, yesterday you are quite off in the chat box. Is there any issue with the chat box, Ishita? Re-NEET का बारे में I don't want to discuss because this is a YouTube platform. In this YouTube platform, we'll discuss only about chemistry and perspectives about the NEET preparation. NEET में अच्छा कैसे कर सकते हैं बस. And I don't want to discuss anything out of that because we have to follow some kind of honesty. I want kind of decency, right? It was a network problem. I know that. Yeah. Okay. आगे बढ़ो. So that's the main course of the today's class. Electrophilic addition reactions. ये electrophile है क्या? Electrophile means, I just want to say one thing here. Reaction attacking reagents are electrophiles and nucleophile. Here HBr, you just want to take it is written as Hu plus and Br minus, है ना, right? So this Hu plus, this Hu plus, it is an electrophile. And Br minus, this is called a nucleophile. Electrophile, phile means seeking, electron seeking group is called electrophile. So this Hu plus is positive charged. So this positive charged species hungry about electron, ये electron की वजह से भूखा है, so that it want to attack, anybody can give the electron, right? So it attack at negative atom or negative group or negative side. And nucleophile, this is a negative charged one, so that it attack a nucleus side. Nucleus का charge क्या है? Positive charge है. So this is a species which attack at a positive charged carbon. Attack at a positive carbon. Such groups are called nucleophiles. You have either nucleophiles or electrophiles. If the addition takes place with electrophile, that is called electrophilic addition. So we are teaching in this YouTube channel, my dear students, from the scratch level. Mind it, you always follow from the scratch levels, you understand everything. So talking about electrophilic addition reaction. In the electrophilic addition reactions of alkene, alkene में जो है pi bond है, this is the pi bond, है ना? This is the pi bond. This pi bond is broken and two new sigma bonds are established. So what I mean to say, you don't look at this. Look at this. Alkene, when X plus and Y minus, so that X plus is attacked here and Y minus is attacked here. So this is an addition reaction. This is an addition reaction, right? So in this addition reaction, electrophile is mediating, so that it is called as electrophilic addition reaction. Understand? Now here, what makes the reaction different from this side? Now you can look at this side. क्या हो रहा है? इसमें एक हाइड्रोजन जगह में एक X सब्स्टिट्यूट कर रहा है. So this is what you call it as substitution reaction. Alkenes कभी substitution reaction में participate करते हैं बस, right? So always they undergo addition reaction by means of a mechanism. They just want to give this mechanism addition of halogen. So let us talk about ethylene. Let us talk about this reaction. CH2 double bond CH2 when Br2 is added in the presence of carbon tetrachloride as a solvent. So what are going to get? I am going to get CH2 and CH2 and Br and Br. So this is electrophilic addition reaction. It takes place in different steps. First step, you see the pi bond जो है ethylene और ethene, ये pi bond जो है ये bromine का polarize कर रहे हैं, so that Br is attacking here, so that a carbocation is formed and Br minus is left. So this is the first. So a classical carbocation is formed in this reaction. Actually non-classical carbocation is also shown here. I want to show in the next slide what is a non-classical carbocation. Now this positive charged carbon is attacked in the second step. In the step 2, this positive charge is attacked by the Br minus, so that you are going to get 1,2-dibromoethane. 1,2-dibromoethane. Clear? So this is about a classical carbocation. What is a classical carbocation? जो carbocation ऐसे हमारा जो पता है, so that is a classical carbocation. Positive charge is clearly appears on a given carbon is called classical carbon, right? Carbocation. But non-classical का वजह से भी discuss कर सकते हैं. I'll show you. Right. Right. Okay. What is a non-classical carbocation? Here I just want to show you. Look at this, my dear children. It's a simplified version. If it is ethene, H, C, H, double bond C, H and H. This is ethene. When bromine is added, bromine is a it is present in the non-polar solvent. What happened? Bromine is a non-polar since it is Br2, but here it is a pi bond. This pi bond is weakly bonded. This pi bond is weakly bonded. The moment the electron is coming towards the bromine, it is getting polarized like this, so that bromine is attacking the Br plus. So carefully you see, it is going to have a cyclobrominium intermediate like this, so that bromine is going to form a cyclobrominium intermediate like this. This is a non-classical carbocation, cyclobrominium ion. That is the intermediate. The term cyclobrominium ion is important in NEET examination. Fine. So, this is lost as a Br minus. That Br minus is going to attack. Br minus is going to attack. As this want to attack, already it want to attack in this side. Already bromine is there, right? So, आगे से काटने का मुश्किल है, इसीलिए ये पीछे से काटने का कोशिश करते हैं. As a result of this, bond is going to be like this. So bromine इस तरफ एक है and opposite और एक bromine घुस गया. So this is what you call it as 1,2-dibromoethane. So as the bromine is attacking from the back side or rear side, पीछे से काट रहा है, so this is called anti-addition. This process is called anti-addition. The term is very very important. Why it is called anti-addition? एक ब्रोमीन इस तरफ काटा और एक ब्रोमीन ऑपोजिट तरफ से काट रहे है ना. दिस इज व्हाट यू कॉल इट एज anti-addition. Hope you are all understanding. Give thumbs up beta इतना मेहनत कर रहे हैं मेरा तरफ से, आप भी कर रहे हैं ना. सो वी ग्रो अप टुगेदर, राइट? कम ऑन. So this is anti-addition. Electrophilic. Meena, Chetan Singh Meena. Thank you. Very good. Thank you. Very good. Nice compliments. My dear students. Love you all. आगे बढ़ना. Thank you, Chetan. So you all understood about anti-addition, na? Fine. Any doubt you want to say, Chetan? बहुत अच्छे से पढ़ रहे हैं, लेकिन सर आप कितनी बार करते हो दिन? Fine. Now let us talk about stereochemistry of electrophilic addition. This stereochemistry of electrophilic addition, it is an extraordinary trick. It is an extraordinary trick. मेरा तरफ से दे रहा हूं आपको. नीट में सीधा इस्तेमाल किया जाएगा. If any kind of difficult question is asked, more than this will not be used here. ATM and car. What is this ATM and car? Anti-addition to transalkene gives meso product, and cis anti-addition gives racemic mixture. Cis alkene on anti-addition gives meso product. So I will tell you, you pick a car, ATM में जाओ, उसमें पैसा लूटो, है ना? स्पैमिंग मत करना बेटा, ओके? स्पैमिंग मत करना. So ATM and a car is a key point in the stereochemistry of electrophilic addition reaction. So what is this? Let us talk about a transalkene. Everybody please focus on the board, okay? Don't spam in the class, okay? Chetan Singh Meena, please focus on the board, dear students, focus on the board. Right. Now transalkene, I just want to take a transalkene as an example like this. This is a transalkene. Don't do anything more. That's good. Please, thank you. Thank you, Chetan Meena. Okay. So cis alkene on anti-addition. So cis alkene है क्या उसमें? Cis alkene CH3, C double bond, CCH3 and H, है ना? So this is the difference between cis alkene and transalkene. So in this cis alkene and transalkene, if you add Br2 in the presence of CCl4, I just want to give you bromine in the yellow color for you. Bromine in yellow color for you, right? Br2. Here also Br2 in the presence of CCl4, right? In the presence of CCl4. We know that this reaction is anti-addition. है कि ना? Anti-addition. So that you don't discuss about ये इस तरफ घुसना, ये इस तरफ घुसना, ओके? ये इस तरफ घुसना, ये इस तरफ घुसना. सीधा ये ट्रिक इस्तेमाल करो, सीधा ये ट्रिक इस्तेमाल करो. It is going to give the meso product. ये meso product है क्या? Meso product आता है like this, CH3, CH3 and Br and Br and H. Now this is a meso product क्योंकि ये plane of symmetry के वजह से ये optically inactive होगा. This is what you call it as meso product. समझ में आ रही क्या? Clear? Understood? जब cis alkene आता है ना, cis alkene on anti-addition gives racemic product. ये racemic product है क्या? Racemic product आता है आपका. So it is going to be CH3, CH3, Br अपोजिट में आना है, इसका मिरर इमेज भी निकालना है. So you practice along with me, my dear students. So if you take its mirror image of this, so you take this in the mirror image, you will be getting the product like this. So carefully you see, इसका mirror image आपका मिल जाएगा आपको CH3. Okay, this bromine come in front of it. Okay, bromine and bromine. So this is an optically active compound. Mixture of equal amounts of optically active compounds is called as, what do you call this? Is a racemic mixture. This is a racemic mixture. My dear students, फिर भी आपको बता रहा हूँ, इट्स नीट एग्जामिनेशन में काफी इंपॉर्टेंट है स्टीरियोकेमिस्ट्री ऑफ इलेक्ट्रोफिलिक एडिशन रिएक्शन. आई थिंक एवरीबडी अंडरस्टूड अबाउट दिस ATM and car. Any doubt? Any doubt? Chatan Singh Meena, Ishita, Richa Sharma, fine, great. Any doubt? You please take a snapshot of this. 1, 2, 3. Click. Okay. आगे बढ़ोगे? Fine. So this is what he said. If it is, this is what you call it as malic acid. Okay. And anti-addition it is going to give, again it is a cis. This is a cis alkene. This is an acid group, but you look into, this is a cis alkene. If you add Br2 in CCl4, what happen? Br2 is going to add the other side, so that you are going to get a mixture of D and L isomers, so that it is a racemic mixture. And you can see a transfumaric acid, okay. It's a fumaric acid anti-addition meso product, okay, and it is a malic acid. It is a malic acid, it's in a cis isomer. Let's talk about fumaric acid is a trans isomer. If you get ATM, anti-addition to trans alkene gives a meso product. This meso product you are going to get like this. Meso product is optically inactive due to presence of plane of symmetry. Here in the case it's a cis, so that you have to use CAR. Cis alkene on anti-addition gives a racemic mixture. Fine, clear? That's good. Fine. Ishita, good, great. God bless you. Okay. So that's what I want to say. Addition of HX, ये भी खतरनाक है, वो भी खतरनाक है, अच्छा बात है. So HX, HX का मतलब क्या है यहाँ पर? HCl होगा. X is a halogen. X is a halogen बेटा. Halogen में fluorine, chlorine, bromine, iodine, 4 things will come. But when it comes to the fluorine, we don't use fluorine in regular basis and in the regular reactions. फ्लोरीन का बिहेवियर जहाँ पर इसका केमिकल रिएक्टिविटी बिल्कुल एनॉमलस अलग होता है, ठीक है. फाइन. एडिशन ऑफ हैलोजन एसिड्स, हाइड्रोक्लोरिक एसिड, हाइड्रोब्रोमिक एसिड, हाइड्रोआयोडिक एसिड, हाइड्रोजन क्लोराइड, हाइड्रोजन ब्रोमाइड, हाइड्रोजन आयोडाइड, these are called HX. So it is an unsymmetrical electrophilic addition reaction. When it is go H plus and X minus, if H plus यहाँ काटना है, X minus यहाँ काटना है, okay, जो भी उल्टा भी हो सकता है, right? Now you can see here H plus is attacking here and X minus is attacking here, right? So that you are going to get a product like this, alkyl halide. You got it, alkyl halide. So if it is HBr, so H plus and Br minus, so that here H plus attacks here and Br minus attacks. I am going to show you the mechanism also. Ethene on addition with HBr, you are going to get ethyl bromide or bromoethane. It is an electrophilic addition reaction. Sir, how do you say it is an electrophilic addition reaction, sir? हाँ मेरा पास ये mechanism देखना. So first let's see the mechanism of the step 1. HBr is ionized as H plus. सबको ये mechanism सही तरह का देख रहे हैं ना, H plus and Br minus है ना. पहला जो H plus है, ये H plus से ये pi bond H plus काट रहे हैं, so that H plus can attach here or H plus can attach here, so that let us say H plus is attached here, so that CH2 plus and CH3 a carbocation is generated, right. This carbocation is going to attack. बाकी जो Br minus है ना, ये काट के आपका मिलेगा ब्रोमोइथेन, आपका कार्बोकैटायन इज द प्रोडक्ट. ठीक है. लेट्स टॉक अबाउट एडिशन. द ऑर्डर ऑफ रिएक्टिविटी of this HI, HBr, HCl, that's very important. HBr, HI, HCl follows the order like that. HI is more reactive than HBr is more reactive than HCl, क्योंकि इसका बॉन्ड एनर्जी बहुत कम है, इसका बॉन्ड एनर्जी और ज़्यादा है. Therefore HI 300 किलो जूल्स देखना आपको पता चलेगा, and HBr 360, HCl 430. सो जिस बॉन्ड एनर्जी कम है वो ज़्यादा रिएक्टिव है, क्योंकि ये बॉन्ड तोड़ने का आसानी कम है. So that lower the bond dissociation energy, more reactive is the halogen halide. Not only halogen halide, कहीं भी पूरा केमिस्ट्री में इस्तेमाल करो. This particular line is the key. More is the reactive. Anywhere in the chemistry you can use this. ठीक है? Fine. Okay. So the actual product formed, however, depends upon whether the alkene is symmetrical alkene or asymmetrical alkene. ये symmetrical alkene क्या, unsymmetrical alkene क्या? Resha Sharma, any doubt with that? Any idea about symmetrical and unsymmetrical alkene? If you have any doubt, any idea, you just tell me. I am going to proceed from there. Okay, symmetrical alkene means you can see CH3 CH double bond and you can see unsymmetrical means CH3 CH2 CH double bond CH and CH3. ये दोनों में ऑब्जर्वेशन का वजह से क्या फर्क पड़ता है देखो. इफ यू सी दिस इज द alkene, this alkene double bond is there, both side of the double bond the same groups are present. So, दोनों तरफ groups are same, right? Same substituents, Ishita correct. If you look at this double bond, ये अलग है, ये चीज अलग है. No doubt. Richa, great. So let's talk about, so when a symmetrical alkene or unsymmetrical alkene is there, how do addition to symmetrical alkene? So addition to unsymmetrical symmetrical alkene कुछ तकलीफ नहीं होगा, सीधा प्रोडक्ट बना सकते हैं. HBr is added, ethene, HBr is added, so you got a bromoethane. So hydrogen यहाँ पर लग गया, okay, H plus and Br minus, right? हाँ, who is that magnet? First, hi guys, sir, don't say hi to sir, magnet. नाम क्या बेटा? Okay, now this is also H plus and Cl minus. You are going to get 2-chlorobutane. Fine. Fine, any doubt? This is about symmetrical alkene. When alkene is symmetrical, only one product is theoretically possible. My dear student, this is example 1 and this is example 2. Right. Now, अगर अनसिमेट्रिकल alkene आएगा तो so this is mechanism we discussed. Addition to unsymmetrical alkene, this is very important. This is very important. So when unsymmetrical alkene is used, so what happened? So HBr, I can get H plus and Br minus. So I can get H attack here and Br attack here. There are two possibilities. अगर Br यहाँ पर attacked, so 2 bromopropane is formed. When Br is attacked here, 1 bromopropane is formed. Two different products are going to be established. When the alkene is unsymmetrical, two products are theoretically possible. उसमें एक major होगा और एक minor होगा. So major means the more amount of substance, more amount of the product is formed. The minor means less amount of product is formed. So आपको कैसे पता चलेगा ये major है ये minor है? Any doubt or any idea about this, you please propose in the chat box. Hello magnet. Okay, let us talk about the mechanism of this. This is governed by two things. Theoretically, one is Markovnikov rule and another one is a stability of the carbocation. So let's talk about the same. Who is this? So propene. So let's talk about propene. CH3 CH double bond CH2 है ना. If HBr is added, HBr means आपका H plus है ना. So HBr gives rise H plus and Br minus है ना. So if उसमें इलेक्ट्रोफाइल क्या है H plus है, न्यूक्लियोफाइल क्या है Br minus है. So electrophile H plus it can be added. So you will get, अगर H यहाँ लग जाएंगे तो कार्बोकैटन यहाँ मिलेगा, अगर H यहाँ लग जाएंगे तो कार्बोकैटन यहाँ मिलेगा है ना. So that I just want to discuss two types of carbocations that are generated, CH3 CH CH3. So H plus egg लग जाएगा, so that carbocation is formed. If H plus is attacked here, so that you are going to get CH3 CH2 and CH2 plus. So there are two types of carbocations, possible carbocations, two are formed, right? So in this possible carbocations, this is a secondary carbocation, this is a primary carbocation. It has only 2 alpha hydrogens, it has 6 alpha hydrogens. Therefore, which is more stable, you tell me, primary carbocation or secondary carbocation? Ishita, which is more stable, you tell me? Yes, that's good. This is a more stable. This is more stable, right? And this is less stable. This is less stable. So more stable, more will be its formation. Less stable, less will be its formation. So a major product is always formed by its more stable carbocation. So that is Br minus is attacked here. So that CH3, CH and CH3 and Br. So this is a major product. Whereas secondary it is correct. Okay. Now Br minus, you are going to get CH3, CH2 and CH2 and Br. So this is going to be the minor product. Fine. This is the major product. So ये major minor बोलने के लिए एक mechanism का तरीका होता है. That is the reason why it is given as a major product and it is a minor product. But also you can say this, for us alum, it is true. It is true. Any electrophilic addition reaction is a anti-addition product, right? So let's talk about theoretical explanation. It is given by a great personality, Markovnikov rule. This Markovnikov rule says negative part of the reagent. Okay, negative, let us say negative part of the reagent. Look at this, CH3, CH double bond CH2. When HBr is added, HBr में Br minus is negative, H plus is positive, right? Negative part of the reagent attacks at a carbon of double bond which bears the least number of hydrogens. So carbon of double bond, 2 hydrogens है, carbon of double bond सिर्फ एक ही हाइड्रोजन है. So negative part of the reagent यहाँ पे काटने का संभावना है. This is what you call it as Markovnikov rule. It is said addition of hydrogen halide to alkene is an electrophilic addition reaction. Thus during addition HBr to propane, the first step involves the formation of a protonated alkene. So it forms a carbocation, है ना. 1,2 methyl shift होता है. Rearrangement जब होगा, Markovnikov rule, don't use it. You want me to show that example for azalam? Definitely I'll do it, है ना. Okay, this is what you call it as Markovnikov rule, so that you're going to get a product CH3, CH3 as a major product. Simple example, simple definition, you just memorize it. So this rule is not so good. Yes, for azalam, not always valid. What you said is correct, because wherever rearrangement is there, this rule you please don't follow, because Markovnikov rule is used only for no rearrangement reactions. For us, what you said is correct. Okay, you want me to say one more example here, peroxide effect. Okay, right. Yeah, let's talk about. Faraz is asking, Muhammad Shahid, hi. You are not coming every day, Muhammad? Mohad Shad, okay, sorry, I mispronounced your name. You want me to give rearrange the product? Yes, definitely. Whenever carbocation is formed in a chemical reaction in organic chemistry, if chance is there, there is going to be always a rearrangement product. So less stable carbocation should form a more stable carbocation, right? That's good. Shad, let's take an example. I just want to discuss for rearrangement example. Yes. Okay, let's talk about it. This example CH3, as you requested, I just want to give immediately this example, right? So that is 3-methyl-but-1-ene, 3-methyl-but-1-ene. When this 3-methyl-but-1-ene is added with HBr gives rise H plus and Br minus. So this H plus can attack here, so that you are going to get the possible more stable carbocation. So this is CH3 and H and CH and CH3 positive. So what kind of carbocation it is? It is a secondary carbocation. So secondary carbocation is less stable. Therefore, what happened? This hydrogen from here shifted from this place to this place. This is what you call it as rearrangement 1,2 hydride shift. That is what you call it as 1,2 hydride shift. So H minus is going to be shifted from this carbon atom to this carbon atom. So you are going to see the formation of the more stable carbocation, so that you are going to see CH3. Children, carefully you see, most of the students has the same problem in understanding these carbocation rearrangement reactions, mind it. Okay, as the hydrogen is moved from here to here, this becomes CH था, अभी CH2 बन गया, अभी CH3, so that H माइनस यहाँ से यहाँ तक चले गया, इसी के कारण यहाँ पर C प्लस बन गया. So this is a tertiary carbocation. This is a tertiary carbocation. This carbocation, I know it is more stable. Tertiary carbocation and primary carbocation and secondary carbocation. Tertiary carbocation is more stable than secondary carbocation, more stable than primary carbocation because of the hyperconjugation as well as positive inductor effect, right? So that if Br minus is attacked, so Br minus is going to attack from here to here. So you are going to get a product, rearranged product. That rearranged product is going to be unexpectedly CH3, Br, CH2 and CH3. If you want to use Markovnikov rule, a rearrangement में Markovnikov rule नहीं चलेगा. ऑक्सीमर्करेशन डीमर्करेशन को बता दीजिएगा, हाँ पक्का. ओके, इफ नॉट टुडे टुमारो आई एम गोइंग टू टेल, बिकॉज और ज़्यादा एग्जांपल्स भी करना है ना. अंडरस्टैंड? क्लियर? फाइन. फराज, you please attend tomorrow's class also. Tomorrow's class I am going to explain oxymercuration, demercuration. ठीक है बेटा? Fine. So let's see peroxide effect. Peroxide effect, this is also called as Karash effect. Peroxide effect is also called as Karash effect. Actually, many students have a misconcept in this peroxide effect. So whenever product is formed according to Markovnikov addition, that is called Markovnikov rule or Markovnikov addition. Here peroxide के वजह से product उल्टा हो रहा है. So here whenever propane is treated with HBr, you are going to get 1-bromopropane as a major product, but not 2-bromopropane. So this is disturbed by peroxide. This is a benzoyl peroxide. This benzoyl peroxide makes the reaction in a different way. Actually, you use CH3, CH double bond CH2, HBr, here is also HBr, peroxide. Okay. Now I just want to say its products and also its mechanism. You are going to see CH3, CH and CH3 and Br and CH3 and CH2, CH2 Br bus. इतना काफ़ी है. It is a Markovnikov rule and it is anti-Markovnikov addition. There is no rule called anti-Markovnikov rule. There is an addition that is taking place against to Markovnikov rule. So you say it is an anti-Markovnikov addition. In this anti-Markovnikov addition, you can say it is electrophilic addition reaction. Okay, and it is a free radical addition reaction. ये काफ़ी important है. Very important is a free radical addition reaction. So this peroxide effect only and only applicable for HBr, but not with HCl, but not with HI, but not with HF. HF is out of the game, right? So this is described by a scientist, so it is also called as a Karash effect. Okay, any peroxide you can say. Here benzoyl peroxide is used as the solvent here. So let's talk about free radical addition reaction for this. Let's talk about the mechanism. Right, mechanism. So addition of HBr to alkene in the presence of peroxide occurs by free radical mechanism. That is a free radical addition. Free radical addition mechanism, right? So this is your benzoyl peroxide. This benzoyl peroxide, benzene ring, C double bond O, C double bond O, COO, C double bond O, C6H5. So this is a peroxy linkage. This peroxy linkage undergo homolysis. As this undergo homolysis, you are going to get a benzoyl free radical. This benzoyl free radical, this is your benzoyl free radical, you can say, yes. This benzoyl free radical, the electron here, this is benzoyl free radical here. Yes, this is your benzoyl free radical. This benzoyl free radical, dear students, you can see, you need not have to propose the same mechanism in the entire NEET examination. You just follow, this is addition reaction followed by free radicals. So this electron pair present between the benzene ring and C double bond O is going to homolyze again to give rise carbon dioxide and phenyl free radical. This phenyl free radical, of course, it is unstable. It is going to attack on HBr, and so that it generates benzene and C6, H6, C6 and H6 and bromine free radical. And this is generation of attacking free radical is called initiation. Any free radical mechanism, children, initiation and propagation and termination, 3 levels of reactions will be there, 3 different steps of reactions will be there, and consist of propagation. So this was initiation, now we are into propagation. In this propagation, 2 steps are there. Step 1, attacking of bromine free radical to alkene to give rise a more stable free radical, secondary free radical. This secondary free radical is going, this is only single bond beta, single bond, not a double bond, single bond. This free radical is going to abstract one more proton to give rise one bromopropane as a major product. So, and this is how the product is generated. Once the product is generated, जो free radicals बचा हुआ वो free radicals collapse करके reaction terminate कर रहे हैं. So the third step is going to be termination. In this termination, so 2 bromine free radical मिला के bromine बन गया, okay, and secondary free radical मिला के 1,2-dibromo-propane बन गया. So here this can also join to give rise 1,4-dibromo-2,3-dimethyl-butane. So these are the various side products that can be formed during free radical addition of alkene with HBr. So these are chota mota products, traces of the compound. Ishita, fine? That's great, that's great. So let's continue ahead. So termination is given. So I just want to give you a question, my dear students. Who can give the answer for this? ICl is attached to isobutylene. For us, Ishita, okay. Who is that magnet? Who can give the answer? Fatapat bolo. Just give me the IUPAC name so that I can give you the answer. So electrophilic addition आधा पहुंच गए हमें. So we have to check how much you can give, right? Try, you can try. Your answer could be wrong, but let us do the best. So those students who are regularly attending in the class, appreciated, as the schools are also being opened. So you may be having kind of disturbance in the time adjustment and all. I request you guys, I think you love these lectures, and you please watch the recordings that are available on the YouTube channel Infinity Learn NEET platform, right? So you also join in the Telegram channel so that you will be getting updates, continuous updates on sessions and session materials and everything. My dear students, any answer for this question, Ishita, you try to understand, and for us you tell me the answer. Come on, come on. Right. So ICl is an interhalogen compound, so that it is I plus Cl minus, क्योंकि chlorine is more electronegative. Let us follow Markovnikov rule. So that what happens, Markovnikov rule की वजह से बस, and you follow the trick. If it attack here, it has to attack here only, na? Simple trick. Clear? So the product that you can expect here, it is this one. So methyl group and methyl group gives inductive effect, so that the pi bond can be shifted. So minus and plus, you simply use Markovnikov rule so that the same product is formed. So if you got confused here, you just look at this. I just want to give you the product as Me, okay, and it is CH2 and iodine and chlorine. So chlorine यहाँ पर आ जाएगा, iodine यहाँ पर आ जाएगा. So this is the product. Clear? That's good, Ishita. Talia. Okay, come on. Very good. Now who is going to do for us your favorite structure? Does anywhere Markovnikov rule, if you want to use it, again it is going to create a lot of headache to you. Why? Because strong electronegative groups are there, strong minus I effects are there, therefore electrons are being withdrawn here. Electrons are being withdrawn. What happened? The product. Somebody please help me to give the right product. I forgot how to write the product. If you give a right answer, if you give wrong answer, I am going to correct your answer. Okay, come on. कुछ भी बोलना यार. Ishita, right? Richa Sharma, where are you? Fine. If you can see this, fluorine is electron withdrawing group, as this is an electron withdrawing group. So ये इलेक्ट्रॉन इस तरफ खींचना चाहता हूं, so that this pi bond is going to push in this way. This is what you call inductomeric effect. Because of this inductomeric effect, this pi bond second carbon पे चला है, so that second carbon में negative charge बन गया and first carbon में positive charge बन गया, है ना? So if you want to add HBr ना, now let us say H plus and Br minus. H plus loves negative charge, Br minus love positive charge. So आपका product मिलेगा 1 bromo 333 trifluoropropane. So you just learn this IUPAC system also is very important in hydrocarbons and haloalkanes and haloarenes. Remember? Right. So appropriate explanation I have given, appropriate notes is also printed here. So you can download these notes from the Telegram channel in the PDF format, right? That's the reason why you just focus on the concepts. ठीक है? Now और एक question है, कौन कर सकते हैं question? I am ready. Who can do this question? I am ready. Come on. चलो. Risha, that's good, fine, nice. So, if a question come in the NEET examination, my dear students, you will get question like this only, है ना? So that focus on what is the kind of product you will get. You want me to give the answer? अरे बेटा देखो, this can give टू टाइप्स ऑफ कार्बोकैटायन है ना, सोच लो, आप खुद सोच लो, Me ऑक्सीजन, Me यहाँ पर पॉजिटिव चार्ज है, Me ऑक्सीजन, Me. There are two kinds of carbocations that can be formed, this carbocation and this carbocation, first and second. Which carbocation is more stable, carbocation A or carbocation B? Tell me in the chat box, tell me in the chat box, carbocation A or carbocation B? Alright, I'll give you. Look at this, lone pair of electron, positive mesomeric effect is highly stable. It is highly stable, right Ishita, you said correct. So जिस कार्बोकेटन हाईली स्टेबल है उससे प्रोडक्ट बनाने का आसान काम है. Therefore, if it is attacked with bromine, you are going to get is that clear? Fine. So this is the major product, unexpected major product. Does all follows Markovnikov rule? No. We are not following Markovnikov rule, right? Whenever resonance comes, whenever rearrangement comes, whenever extremely electron withdrawing groups are coming, electron pushing groups are coming, Markovnikov rule is a generalized rule, can be used for simple things but not for little twist coming in the course, right? That's good. Very, very, very important as far as the NEET examination is concerned. Yes, this is the explanation that I want to give you. For that, keep it as a notes. एक notes कैसा मिलेगा? Richa Sharma, you tell me, आपका needs कैसा मिलेगा? You just study, attend the class sincerely, study sincerely, and work sincerely. Attend regularly. You follow the class and make a notes, make a cheat sheet, and follow the materials that are provided, and you can do the best. It is in the NEET 2025 program. You are all sitting with a lot of enthusiasm by sacrificing the 1 year. 1 year can give you the best. Okay, if these classes you follow, you can be a topper in NEET 2025. Mind it, है ना? हाँ, टेलीग्राम चैनल पे मिलेगा. हाँ, perfect, perfect. Now, can you do this? Can you do this? Right? Can you do this? Everybody, take pen and paper and try to do scratch maro, scratch. Yes. Correct? Now, what is happening? This might be the last example. So, जोश का है क्लास में? हाँ, yes, जोश का है. Right. Very good. So, we started classes in almost at the end of summer. We are entering into the monsoon, and we completed successfully so many things. Do you know? Organic part, isomerism we completed, alkanes we completed, general organic chemistry we completed, inductive effect, hyperconjugation, mesomeric effect, resonance, many things we completed. Now alkenes. Now in this alkenes we are getting into the alkynes and benzene. Get ready for this. And in the grade 12 we completed electrochemistry, if you remember. And solutions chal rahe. We are in solutions. And pursue solutions colligative property में last class and questions भी करना चाहता हूँ. So all these classes are absolutely free, and we are doing the best from our side by Infinity Learn. The team from Infinity Learn doing the best. Okay, you are also doing the best but only one thing, be regular. Okay, like मारो ये सेशन का, आपका फ्रेंड्स का ये share the sessions so that इन लोगों को भी फायदा होगा, and subscribe to the channels so that you will be getting continuous updates. So you need not have to pay anything. These sessions are absolutely free, right beta? That's good, very good. So ये क्वेश्चन कैसा कर सकते हैं? ये क्वेश्चन you just see, ये bromine, it has a lone pair of electron, it has a positive isomeric effect. So lone pair and a pi bond, okay, ये conjugation फॉर्म है. So ये conjugation का वजह से आपका ये bromine is going to polarize like this, so that it is going to be negative and a positive. So that ये positive का Br minus काटना, negative का H2 plus काटना. So that what you get 1,2-dibromoethane. So that the same explanation that is given the previous one, right? Fine beta. Yes, who can give you the answer here? It is a triple bond. It is a triple bond. हाँ, 1 mole of HBr, only एक molecule दिया जाएगा आपको. If 1 molecule of HBr is reacted with, what is this? This compound I just want to give you as CH triple bond and C and CH2, okay, CH double bond CH2. This is the structure, right? In this structure, if 1 mole of HBr is reacted, Faraz, where are you? I can't see you. I want to see what is your answer. Whenever double bond and triple bond is there, alkene is more reactive than alkyne in electrophilic addition reaction. Therefore, HBr is added so that you are going to get triple bond is not going to react beta. So it is going to give you CH2, CH and CH3 and Br. So alkene is more reactive than alkyne. Why? Because alkene is going to form a alkyl carbocation, alkyne is going to form a vinyl carbocation. विनाइल कार्बोकैटायन स्टेबिलिटी बहुत बहुत कम है. इसी का देखो, if this is attacked by H plus, secondary carbocation is formed. Secondary carbocation की वजह से the 4-bromopentene 1 is formed. But if a triple bond react करना चाहता हो तो आपको विनाइल कार्बोकैटायन is formed. Vinyl carbocation is unstable. Therefore, alkyne do not react. This is a tremendous example that you can experience in NEET examination better. So, in the NEET examination, you please follow these simple tricks. Simple tricks. Everybody can participate in NEET examination. लाखों के जन लिख रहे हैं NEET में, but a few students are getting NEET ranks. Why? They know these kind of tricks. समझ में आ रहा है क्या? Don't talk about NEET. We talk about NEET का preparation. बस. Yes, my dear students, here today we learned electrophilic addition reactions of alkene. In that hydrogenation, halogenation, hydrobromination, and in that peroxide effect, Markovnikov, every reaction in that rearrangements also we have seen. And so many reactions are left. Tomorrow we are going to see those reactions, ozonolysis and ozonolysis products and everything. So my dear students, you please be regular, please like and share and subscribe this YouTube channel. And you are all doing a great job. Thank you very much. God bless you. Fine. Signing off. Tomorrow we'll meet. Thank you. Bye-bye.